All right, so this video is going to be demonstrating the conversion between a decimal to a binary number. Right. Again, I want to hit basis on the different number systems here. Decimal, or dec, means it's a base 10 number, which means it consists of 10 total characters that can take up one slot or one column. Right, so we know our decimal system. Pretty much we go 1. If we add 1, 1 plus 1 is 2. Add 1 becomes 3. And we do that all the way up to 9. But then once we have 9, if I add 1, it's no longer a single character, right? 9 plus 1 will become 10. Or 1, 0. Right? So if I were to actually 9 plus 1, the 9 becomes the 0, and we carry 1 over. It becomes a 2-character number, right? Notice what I'm doing here. I'm writing to the base of 10, so we know that this is a decimal number. We normally don't write our decimal numbers like this. We assume if a number does not have a base number, then it is within the decimal system. However, with most of this, I'm going to make sure that at least the answers, or when it needs to be clarified, that what number system the number belongs to. Right? But say I wanted to actually convert a decimal number, and I'm going to pick a number 22. 22 base of 10 is equal to what to the base 2, or a binary number. Now, to follow this through, I need to understand how the binary system works. It's very similar to the decimal system. Right? I'm going to draw these all out as ones. Right? And we'll call this, well, we can call it a base 2 number. I'm not saying that this right here represents 22. Okay, I'm just using this as a demonstration. In the decimal system, we count up to 9, and then once we add one more, then we gain, right? And then I can keep adding one to this, and once this gets to 9 again, then I add another one to this one, and it keeps going until this reaches 9, and this is 9, and then we gain another column. And the binary system is actually a lot simpler because there's only 2 digits. Right? So if this was a 0 and I added 1, it's 1. As soon as I want to add another 1, I can't. I can't add it to that column. So it becomes a 0 and I add a 1 over here. Right? So to demonstrate that, here's 0 in the binary system, right? And we add 1 equals 1. Now if I take that 1 and I add another 1, it's going to equal 1, 0. Hopefully you're following that. And of course, if I take this, which is actually the number 2, but if I write it out in binary and I want to add 1, that's going to equal, well, I can actually put a 1 there, so it's going to be 1, 1 base 2. Right? Then following the next one, 1, 1 base 2, and I add another 1. What do you think it's going to be? Right? I have 2 columns here already that are at their maximum character value. So I have to create a new column. If I add 1 to this, it becomes a 0 and we carry a 1. So to show this over here, I'm going to go 11 and then add the 1. These are the max, so it has to become 0, and I had to carry the 1. Well, 1 plus 1 in the binary system don't have a character that represents 2, so I have to put a 0 and carry the 1 to the next column, so it becomes a 1, 0, 0. Hopefully you're following that along. But what we want to focus on is how to convert from decimal to binary and back, which I'm going to start with the decimal to binary. Each column in the binary system has a decimal value. So if I have a 1 in this column, the total value is 1 in decimal. If I have a 1 in this column and everything else is 0, then the value of this column is worth 2 in the decimal system. As y'all can see, 0 plus 1 is 1. 1 plus 1, we know 1 plus 1 is 2 in the decimal, right? But in binary, it's 1, 0. So if this was 1 and this was a 0, then the total value would be 2. We've already gone all the way up to, in this case, the fourth number in binary, which is 1, 0, 0. But to demonstrate that, if this was a 0, this was a 0, and this was a 1, then the total value would be 4. And hopefully you're starting to recognize a pattern here, which is every single column is essentially the previous column times the base number. In this case, binary is a base 2. So following this along, 1 times 2 gives me this column's value. 2 times 2 gives me this column's value. So this column's value is going to be 2 times 4, which is 8. Following that same pattern, the next one should be 2 times 8 is 16. Okay. And if I had another column, it'd be 2 times 16, which would be 32. Next one would be 64, 128, 256. You just keep doubling the number for each column. So now that we understand the decimal value of each character, if it was a 1, this is how we're going to start to convert the decimal number 22 into a binary number. And how we're going to do that is I want to find the number that is larger than 22. Okay? And I'm going to write a 0 under that. You might have to write these out as far as you need to go. Basically, keep going until you come up with a number that's larger than the number you need to convert. Once you've done it, go ahead and stop. We're not actually even going to use that number, but it gives you a good place to stop, right? I'm going to write a 0 here because 32 does not go into 22. I can't fit 32 into 22. However, I can fit a 16 into 22, right? So I'm going to go ahead, if it'll fit, I'm going to write a 1. So 16 goes into 22 one time. What's left over? So I'm going to go 22 minus 16, and what do I get? 6. Right? So now I'm looking for a number that will go into this. 8 will not go into 6. So I'm going to write 0. Will 4 go into 6? Yes, it will. So I'm going to go ahead and subtract that 4, and it leaves me a remainder of 2. Will 2 go into 2? Yes, it will. And of course, I've gotten to 0, so I know from that point out everything else is going to be zeros. So from this, I can say that the decimal number 22 is equal to any leading zeros. You can leave them there if you want to. I won't count off if you have them. But to write it in the shortest number of characters possible, always start with the 1, 0, 1, 1, 0. Now, trailing zeros here, they still count. They still have a value. So the decimal number 22 is equal to 10110 in binary. We'll go ahead and do that one more time. Pick another random number here. We'll say 57. Okay, 57 base 10. And I'm going to go ahead and start out. I'm going to write my 1's column, my 2's column, 4, 8, 16, 32. And remember, I'm going to keep going until I get to a number bigger than 57. The next column is just going to be this number times 2. That's going to be 64. Right? 64 is bigger than 57. Go ahead and write that 0. Right? 32 will go into 57 one time. So I go 57 minus 32. Should leave me, well, with 25. $16 will go into 25 once, so go ahead and subtract the 16. Leaves me with 9 left over. 8 will go into 9 one time, so I go ahead and subtract the 8, and I have a remainder of 1. So So in this case, I can just go ahead and jump straight to 1. That'll give me remainder of 0. Everything else is going to be zeros. So the decimal number of 57 base 10 is going to equal the binary number 111001. I didn't cross all my zeros. A little pet peeve of mine. So understanding that all these numbers up top, we're just using these are our decimal numbers. And we're creating ones or zeros for our binary. Hopefully this has helped you get your decimal to binary. Although the Word document that was provided should already have these probably all the way to number 20. I just want to go ahead and give you a quick reference of the decimal number and its binary equivalent. Right? You can try to just memorize this stuff, but I highly recommend against it. Instead, if you work it out this way, you can always convert any decimal number into a binary number. I will point out that it is very useful to go ahead and have at least the numbers 0 through 16 memorized, or at least 0 through 15, and that's going to help you out later when we're dealing with the hexadecimal system. Okay? If you need to pause to go ahead and write these down as a note, like I said, they are in the Word document. These are very useful to go ahead and have memorized. You don't need to memorize anything after that. And like I say, you don't technically need to memorize even these, but it is useful to have these memorized. All right, so I'm going to move on, and we're going to be talking about how to convert binary back into decimal. So binary to decimal. So again, this is a base 2, and this is base 10. So as I already have here, like I said, that list of numbers that you could try to memorize, you could always, take one of these and go, oh, that's 14, or oh, this is 6, right? But if you want to minimize what you're memorizing, again, you understand. So I'm going to pick a random binary number. I'm going to go 1 0 1 1 1 0 1 1 1 0. Okay. Now this is 1 2 3 4 5 6 7 8 9 10 characters. Right. Now this is the binary number being provided, right? I'm going to do something very similar to what we did with the decimal to binary. Right? And this is the part that some people get confused between the two. Before, you didn't have the ones and zeros. You're trying to figure out what they were. But up top, this is the similarity. Right? Each column has a decimal value, as I explained before. I'm going to start from the right, and I'm going to keep going to the left. And each time, it doubles. 16, 32, 64, 128, 256, 512. So to go from a binary number back to a decimal, this is actually rather simple. All I do is I take the binary digit and I multiply it by the decimal value above it. Okay? And I keep doing that all the way down. And then all of the individual answers, I just add them together. Right? So I go 1 times 0 is 0. 2 times 1 is 2. Now mind you, we're just going to add all these together. 4 times 1. And I guess you're wondering, well, why are we multiplying? Basically, if we just have a 1 here, just take that number and bring it down. which holds true for the binary system when doing, binary to decimal. But there are other number systems where this technique applies, where you have to actually multiply, because this is not just a 1. So it's good to go ahead and get into the motion of multiplying. But if you do notice it, if there's a 1, I just carry that number down. It's going to be 0, 32, 64. Let me actually space this out a little bit. And I'm going to start from the left. And that way I can write it all out. Right? So 512, there's a 1 in that column, so I'm going to write 512. There's a 0 here, so I'm not worried about it. I'm going to add 128, and then I'm going to add 64, and then I'm going to add 32, and then I'm going to add 8 because there's 0 in the 16, so I don't add the 16. The next one is going to be the 4. The next one is going to be the 2, and of course the 1's column is 0, so I don't worry about adding a 1. Now, we normally don't add up this way, right? But you can punch these all into your calculator. I'm going to go ahead and write them all out. Right. Just do some basic math of adding 2 together at a time. It's 10, 4, 6. Okay. And then I'm going to add 64 and 32. That's 96. Then I'm going to go ahead and add these remaining 3 together. 8, 4, and 2. That's 8 and 6 is 14. 8, 4, and 2 is 14. So now I've got 3 numbers I can add together. 6, 40, 96, and 14. That's going to be $750. Right? So the binary number of 1011101110 is equal to 750 in the decimal system, or base 10. Go ahead and go through this again one more time with another random number. And you'll notice I always start with the number 1, because if it's starting with a 0, then it doesn't matter. So I'm going to go ahead and start with 1, 1, 0, 0, 0, 1, 1, 0, 1. And again, I'm going to go ahead and identify the column starting from the right. 1, 2, 4, 8, 16, 32, 64, 128, 5, 12. And so if I got a number in that column, go ahead and multiply the decimal value by that. It's 512. Add in 128. I got a bunch of zeros, so I'm not worried about these numbers. The next one is 8, so I'm going to add 8. Then I'm going to add 4. And then I'm going to add, finally, 1. Okay. Or do you know that 512 and 128 is 640? And these 3 remaining, that's 5 and 8, should be 13. So that should equal 653. So the binary number of 11001101 is equal to 653 base 10. Hopefully you're able to follow along with this, going from decimal to binary and binary back to decimal. If you have any questions, by all means, please get a hold of me. Let me know. We will be having our virtual classroom on the second week, where the first part of it will be a discussion on this to help clarify anything that you'll need prior to taking your quiz.